Okay, so hello everybody. We are going to have a part of trigonometry in today's lesson, and we started with the law of sine. In the figure, we have one inscribed triangle which is surrounded by a circle, and the circle is a circumscribed circle. And the law of size, the ratio of the sides and their corresponding sine measures will give us 2 times radius, which is a over sine a is equal to b over sine c is equal to c over sine c is equal to 2 times r. For the example 55, we have a triangle described, and the measure of angle A is given 30 degrees, and the length of side A is 8 centimeter. We have to find the area of circumscribed circle. Okay, so here is by the law of sines, A over sine A is equal to 2 times R. So 8 over sine 30 is equal to 2 times radius. Sine 30 is a 1 over 2, and 16 is equal to 2 times r, and the radius of the circle will be 8 centimeter. We can calculate the area A of a circle with the formula. The A is a pi times r square, so it's gonna be pi times 8 squared, which is 64 pi centimeter square. For the example 56, a triangle ABC given, the measure of angle B and C 45 and 30 degrees respectively, and the length of side C is 4 centimeter. We are going to find the length of side B. By the law of sines, C over sine C is equal to side B over the measure of sine B. Okay, so the side C is a 4, and the sine C is sine 30 degrees, and B is, we have to find it, and sine 45. Okay, so 4 over sine 30 is 1 over 2, and sine 45 root 2 over 2 cancels each other out, and 4 root 2 is equal to B. Okay, so B is 4 root 2 centimeter. And we have a check yourself 16. That's a very good option to reinforce our knowledge. You can solve the problems for the next time. Okay, in our title we have a formulas for the area of a triangle, and the measure of vertices given A, B, and C. And to find the area of triangle ABC, we have 3 different choices. So the first is by taking product of side A and B, and the measure of side C over 2. For the next area, the half of the product of side A and side C times the measure of side B. And the last one is 1 over 2 times B times C times the measure of sine A. For the example, we have a triangle ABC. The area is given 3 root 3 centimeters squared. Side B and side C 3 and 4. Find all the possible measures of angle A. Okay. So the area of triangle ABC, by taking side B and side C, we can calculate 1 over 2 times B times C times the measure of sine A. So the area is given 3 root 3 centimeters squared, so 1 over 2 times, we're going to put in the place of B and C 3 and 4, and from here we will get for sine A is root 3 over 2. Okay, and we know that sine 60 is equal to sine 120, which is root 3 over 2. So the possible measures for angle A is 60 degrees or 120 degrees. Okay. For example 59, a triangle ABC, area 5 centimeters square, and by taking this knowledge, we are going to find the area of triangle ADE. Okay, we're going to figure it out. The area of triangle ABC by taking AB and AC and we have to take acute angle, which is A, and the area is a given 5. So 1 over 2 times side AB is a 5 and side AC is 7 and sine A. So the value of sine A will be 2 and 7. Since angle A is a common to both triangles for ABC and for AED, we can use the value of sine A for both triangles, and to find the area of triangle ADE, we write 1 over 2 times side AD times side AE times the common angle, which is A, and 1 over 2 times 4 times 7 times sine A was 2 over 7, cancels each other out. So it's gonna be 4 centimeters square, the area of triangle ADE. For the next part, we have a Heron's formula with the given sides, and there's nothing else. How can I find the area of triangle? And first, we will find here the perimeter, which is 2u. And then, to find the area of triangle, we use the root, the half of the u times u minus a times u minus c, and u minus b. We are going to take difference between u and all sides. So for the example, the sides are given by Heron's formula. Let 2u is equal to a plus b plus c. So u is 9 plus 10 plus 11 over 2, which is 15. And the area of triangle ABC, the root 15 times 15 minus 9, which is 6, 15 minus 10, 5, and 15 minus 11 will give us 4. And at the end, we will have for the area of triangle ABC 30 root 2 centimeters square. For the next problem, the side AB, side AC, and sides BC, 6, 10, and 12 centimeters respectively. And we are going to find side AD, which is height of the triangle. It is. Okay. And we can find the area of triangle by taking half of the product of base and height, or from the Heron's formula. Okay. So from Heron's formula, the 2u is equal to a plus b plus c, and the u will be from here as a 14, and the area of triangle ABC, the 14 times 14 minus 12, 2 times 14 minus 10, 4, and the last side is 6. It'll be 8. So it's gonna be 8 root 14 centimeters squared. That is the area. And also we have another approach to find the area of triangle ABC. Base times height over 2. So the side BC times height AD over 2. What is the area? We got this from the Heron's formula. 8 root 14 is equal to, and the side BC is at 12 times the side AD, is x over 2. Cancels each other out, 6. So the value of x will be, by reducing to fraction, 14 root 14 over 2 centimeter. Okay. On the next part, we have area of an inscribed triangle. Let ABC be a triangle with sides A, B, and C, which is inscribed in a circle with radius R. Then the area of ABC is the ratio of the product of the sides and 4 times radius. For example, 62, the sides are given 5, 6, and 7, and we're going to find the radius of the triangle, circumscribed circle, yeah. And I'm going to start to solve the problem by finding the area of triangle ABC by using the Heron's formula. The 2u is equal to a plus b plus c, so the u will be here as a 9. And the area of triangle ABC, by taking root 9 times 9 minus 5, 4, 9 minus 6, 3, and 9 minus 7, 2, we will get 6 root 6 centimeters squared. That is the area. Okay. And also we learned that for the inscribed triangle, the area is ABC over 4R, and we are going to compare 6 root 6 is equal to the sides ABC 5, 6, and 7 over 4 times R, which is 210 over 4 times R. And at the end, for the radius, we will get 35 over 4 root 6 centimeter. Okay. Okay, another part is trigonometric formulas. First, we're going to start with the sum and difference formulas. And we have here is a sine x plus y and sine x minus y. Okay, we learned that how can we find the measure of 0, 30, 45, 60, and 90 for sine and cosine. And to find the measure of sine 75, we are going to split 75 in 40 and 45 and 30 degrees. And after that, all we need to do is use here the sum formula for sine. X plus y is sine x times cosine y. And plus cosine x times sine y. So we will use the original formula for the sum. Sine 45 times cosine 30 degrees plus cosine 35 times sine 45 degrees. Sine 45 is root 2 over 2. Cosine 30 is root 3 over 2 plus cosine 35 root 2 over 2, and sine 30 will be here is a 1 over 2. Okay. And from here we get for sine 75 root 6 plus root 2 over 2, right? Okay. What about sine 15 degrees? By taking difference formulas, we can write 15 degrees as 45 minus 30, or 60 degrees minus 35 degrees, or any other suitable combination. So let us choose 40 degrees and 35. So sine 15 is equal to sine 60 degrees minus 45, which is, let me take the difference formula over here. sine 60 times cosine 35 minus cosine 60 times sine 35. And from here we will get for sine 15 is root 6 minus root 2 over 4. Okay. And after that, we're gonna see here the sum and difference formula of cosine. And the first is the cosine x plus y. And we can split 105 degrees in 60 degrees and 45 degrees. Okay. Okay, according to some formula for cosine, we write cosine 60 degrees times the measure of the secant 45 and minus sine 60 times sine 35. Cosine 60 is 1.5 cosine 45 root 2 over 2 minus sine 60 is root 3 over 2 and sine 45 is root 2 over 2. And after that, we're going to have for cosine 105 degrees root 2 minus root 6 over 2. Okay. Or by taking differential formula, also we can find the measure of cosine 105. So if we're going to split 105 in cosine 150 minus 35. But I'm going to let you solve it, okay? So for example 69, we have sum and difference formula for tangent. Okay. And the question says verify that tangent 210 degrees is equal to root 3 over 3. So by splitting 210 in 180 and 30, okay. So the tangent 210 degrees is equal to tangent 180 degrees plus tangent 30 degrees by the formula over here. And then 1 minus tangent 180 degrees times tangent 30 degrees is equal to tangent 180, which is 0, plus root 3 over 3 over 1 minus 0 times root 3 over 3, and we will get for tangent 210 degrees root 3 over 3. And also we have here the difference formula for tangent. So it's going to be tangent x minus tangent y over 1 plus tangent x times tangent y. We are going to have just the inverse operation. That's it. And we have cotangent x plus y and cotangent x minus y. To calculate cotangent 75, we can divide 75 into 45 and 30, right? So the cotangent 75 degrees is equal to cotangent 45 and 30 degrees. And we are going to use here the original formula, and we will put the values for x 45 for y is 30 degrees. So it's going to be cotangent 45 times cotangent 30 and minus 1 over cotangent 45 plus cotangent 30 degrees is equal to cotangent 45 1, cotangent 30 is root 3 minus 1 over 1 plus root 3. Okay. So we can get rid of this irrational denominator by taking conjugate of 1 plus root 3. So it's going to be 1 minus root 3. Okay. So by multiplying these irrational numbers, we will get 2 minus root 3. Okay. For the next part, we're going to talk about it, which is double angle and half angle formulas. So we know formulas to calculate trigonometric ratios such as sine x plus y, cosine x plus y, tangent x plus y, and cotangent x plus y by using some formula. And in this section, we'll consider the special case x is equal to y and find formulas for the trigonometric ratios sine 2x, cosine 2x, tangent 2x, and cotangent 2x. These formulas are called the double angle formulas. The first is sine 2x. Okay. For 2x, we can write x and x, right? And after that, by using the sum formula, sine x plus y, remember this. It was sine x times cosine y plus cosine x times sine y. So the measures are same. So when we put it, we will get here sine x times cosine x plus cosine x times sine x. It is 2 times sine x times cosine x. That is the double angle formula for sine. If we're going to divide both sides by 2, we will get for sine x times cosine x is equal to sine 2x over 2. For example 72, we will find the measure of sine 120 by using the double angle formula for sine. Okay, so 120 degrees is equal to 2 times 60 degrees. And what is sine 2 times 60 degrees, which is 2 times sine 60 times cosine 60, right? Because it was sine 2x. Okay. And sine 60 is root 3 over 2 and cosine 60 1.5. So we will get for sine 120 root 3 over 2. And remember this, also we can find the measure of sine 120 by taking difference between x-axis and the given measure. That is the second quadrant. On the second quadrant, the sign is a positive. So we have to find actually sine 60 degrees, which is root 3 over 2. For example, 73, and the first, we're going to evaluate the measures sine 22.5 degrees, cosine 22.5 degrees times cosine 45. The measures are same, and directly we can focus on the double angle formula. But first remember this, sine x times cosine x was sine 2x over 2, right? So sine 22.5 degrees times cosine 22.5 degrees is equal to sine 2 times 22.5 degrees over 2. So it's gonna be sine 45 over 2. It means that for the first two expressions, which is sine 22.5 and cosine 22.5, I'm going to write sine 45 degrees over 2. By writing this, we will figure it out. Okay. So it's gonna be sine 35 over 2 times cosine 35. Okay. What is sine 45 times cosine 45? So it's gonna be sine 2 times 45 degrees over 2, which is sine 90 degrees over 2, right? Okay. So I'm going to take sine 35 and cosine 35 and we'll replace sine 90 degrees over 2 over here and divide it by 2. Sine 90 is a 1.5 divided by 2, keep switch. and we will get 1/4. Okay. And I want you to solve the seconds. 6 times sine pi over 8 times cosine pi over 8. For the example 74, we're going to find cosine 6x over cosine 2x minus sine 6x over sine 2x. First, we will equalize the denominator, so I'm going to multiply cosine 2x by sine 2x and sine 2x by cosine 2x. When we multiply at the top, we will have cosine 6x times sine 2x minus cosine 2x times sine 6x. Okay. And divided by cosine 2x times sine 2x. And it's gonna be the difference of sine formula, right? Remember sine x minus y. So it will be sine 2x times cosine 6x minus sine 6x minus cosine 2x. That is the difference formula for sine. So the top will be, we're going to have sine 2x minus 6x, which is sine minus 4x divided by sine 2x times cosine 2x. Okay. For sine minus 4x, we are going to apply here the symmetry formula. What is the symmetry formula? If we are going to have full x, it's going to be on the first quadrant. On the first quadrant, the measure of sine is a positive. So what is the meaning of sine minus 4x? We are going to move clockwise rotation, so it's going to be minus 4x. So it will be on the fourth quadrant, right? On the fourth quadrant, the measure of sine is a negative. So because of that reason, the measure of sine minus x is equal to minus sine x. What about cosine? Cosine minus x, when we compare with the first and the last quadrant, so minus x will be on the fourth quadrant, and on the fourth quadrant x is a positive, so for the symmetry formula of cosine, it will give us positive cosine x. For tangent minus x, minus tangent x, and for cotangent minus x, by taking the ratio of cosine x over minus sine x, it's gonna be a minus cotangent x. That is the symmetry formula. That is the symmetry formula. Okay. And sine minus 4x, it's gonna be minus sine 4x over, by taking double angle formula, cosine 2x times sine 2x will be sine 2 times 2x over 2, which is sine 4x and a half. They cancels each other out, and a minus 1 over 1 over 2 will be negative 2. Okay. For example 75, and 4 times cosine 50 degrees times sine 50 times cosine 100 degrees over sine 200 degrees. We can rewrite this as the 2 times cosine 50 times sine 50 degrees times cosine 100 degrees divided by sine 200 degrees. And use sine 100 degrees. What is that? Sine 100 degrees, 2 times sine 50 times cosine 50 by using the double angle formula. And it means I'm going to put, instead of parentheses, sine 100 degrees times cosine 100 degrees divided by sine 200 degrees. Okay. And that is double angle formula. It's going to be sine 2 times 100 degrees divided by sine 200 degrees. They cancels each other out, and we will get just 1. using the double angle formula again. Okay, for example 76, we have to evaluate sine 20 degrees times cosine 30 times cosine 80. Okay. Let's suppose that they are equal x, and if I'm going to multiply both sides by cosine 20, from the first two measures we will get sine 40 degrees over 2, right? And cosine 40 times cosine 80 is equal to x times cosine 20 degrees. And by taking first and the second, which is sine 40 and cosine 40, which happens to be sine 80 degrees over 2 times 1 over 2 times cosine 80 degrees is equal to x times cosine 20. For sine 80 and cosine 80, it's going to be sine 160 divided by 2, and 2 times 2, which is 4, is equal to x times cosine 20 degrees. And after that, what is the measure of sine 160? Or what is the measure of cosine 20 degrees? They are equal, right? Okay. So at the end, for x's, we will get 1 over 8 and the tangent 20 degrees. Okay. Because sine 160 degrees, we know that it is a sine 20 degrees over 8 is equal to x times cosine 20 degrees. Okay. And if I'm going to multiply both sides by 1 over cosine 20, they cancels each other out, so tangent 20 is equal to 8x. So for x's, we will get 1 over 8 tangent 20 degrees. Okay, for the next, we have double angle for cosine. So cosine 2x will be cosine square x minus sine square x by using the sum formula. And after that, we know that from the trigonometric identities, sine square x is 1 minus cos square x, and cos square x is 1 minus sine square x. Okay. For the first, if I'm going to put in the place of sine square x is a 1 minus cos square x, it's going to be cos square x minus 1 plus cos square x, which is 2 cos square x minus 1. For the second, in the place of cosine square x, I'm going to put 1 minus sine square x, and we will have 1 minus 2 sine square x. We have 3 different options for cosine 2x. And which one is more practical? It depends on the problem. We can take one of them. For example, 77 and 78, take a look. Cosine x is given root 7 over 4, and the measure of x is between 0 and pi over 2, which is first quadrant. Cosine is a positive. And the double angle formula for cosine is 2 times cosine square x minus 1, which is 2 times root 7 over 4 square minus 1. So we will get negative 1 over 8. For the next problem, we will find the ratio of 1 minus cosine 2x and 1 plus cosine 2x. Cos 2x is 1 minus 2 sine square x, and cos 2x is by taking the second 2 cos square x minus 1. And we are going to simplify and rearrange. At the end, we will have 2 sine square x over 2 cos square x cancels each other out, 2's. And what is sine square x over cos square x? It's going to be tangent square x. Okay. For example, 79, the cosine 11 degrees is given as t, and we will write sine 68 degrees in term of t. We know that sine 68 and cosine 22 degrees, they are cofunctions, right? Okay, why? Because the sum of their measures uh, will be 90 degrees. So, okay. And for cosine 22 degrees, when we are going to apply double angle formula, it's gonna be 2 cos square x minus 1, right? Okay, cos 2x is 2 cos square x minus 1, and we are looking for 22 degrees. So it's gonna be 2 cos square 11 degrees minus 1. And cos 11 is a t, so cos square 11 degrees will be t squared. And we will have for cosine 22 2t squared minus 1. For the next part, we're gonna see here the sum double angle formula for tangent and cotangent. Let me tell you directly the formulas. So 2 tangent x over 1 minus tangent squared x, that is the double angle for tangent. For cotangent, cotangent squared x minus 1 over 2 cotangent x. Okay. And how can we prove the formulas? By using the sum formulas for tangent and cotangent. Okay. For example, 82, cosine 2x is given negative 1 over 5, and we will find cosine x if x is in the first quadrant. Okay. So cos 2x is equal to 2 cos square x minus 1 is equal to, and from here, if we are going to isolate cos x, I'm going to take negative 1 to the left side and divide it by 2. It will give us cos square x by taking root of both sides. Cosine x will be plus minus 1 plus cosine 2x over 2, right? Since x is in the first quadrant, the cosine is positive. So cosine x is equal to 1 plus negative 1 over 5 and a half. So we will have root 2 over 5. Okay. For example 86, the cotangent x over 2 is given t, and find sine x in term of t. And we can show cotangent x over 2 is equal to t in the right triangle is given below here. Okay. And x over 2, and what is the ratio of cotangents in a right triangle? The adjacent over opposite, right? Okay, so if adjacent over opposite is t, so we can take for this side is a t and for this side is a 1. So for x over 2, adjacent side is t and the opposite is a 1. T over 1 is t, which is cotangent x over 2. By using the Pythagorean theorem, we can find the hypotenuse. What is the hypotenuse? T squared plus 1. Okay. From the double angle formula for the sine, we have sine x is equal to 2 times sine x over 2 times cosine x over 2. And what is sine x over 2? Opposite over hypotenuse, which is the 1 over root t squared plus 1 times cosine x over 2 adjacent over hypotenuse. So it's gonna be t over root t squared plus 1. And we have 2 times t divided by t squared plus 1. Okay. And we have check yourself 20. Okay. I would like to finish the lesson here. Thank you very much. Have a nice day.